we'll be seeing about thermodynamics. Thermo means heat and dynamics means motion or flow. So thermodynamics basically deals with the flow of heat. Let's see some terminologies. System, surrounding and boundary. Now let me draw to make you understand. Now let's say this area is our system, right? So this is where the thing takes place. This is called the system. And now beyond that, all the rest of the places are going to be called surroundings or the universe. And the line that separates, the border that separates the surrounding and the system is called the boundary. Now, systems are of few types. That is open, closed, isolated, homogeneous, and heterogeneous. Open, closed, and isolated are basically based on the classification that is based on the exchange of the heat that happens. So, like if I give you an example, like open system would be, for example, a cup of tea, right? So the energy exchanges with the surrounding, and also the matter also changes with the surrounding. But now, if you put a lid on top of that teacup, then the energy is exchanged, but the matter is not exchanged. So that will be an example of closed system. Whereas an isolated system, we can take example of a thermos, right? So when you put hot tea into it, it stays hot. So there's no energy that is exchanged, or there is no matter also that is exchanged because it's closed, right? So this is based on the exchange of the heat. Now we have classification based on the particle nature, that is homogeneous and heterogeneous. So if the phase that is present is uniform in the entire system, that is the whole system is solid, taking place in solid or liquid or gas, then it is homogeneous. Whereas if there is this change in the phase, then it's heterogeneous. Okay, so now let us look into properties of the system. There are three major properties, that is intensive, extensive, and macroscopic. In intensive, the nature of the substance matters, but the amount of the substance does not depend. So, for example, maybe temperature or pressure, density, etc. Whereas in extensive, the amount is the one that matters, but the nature is not what the property basically depends on. Like if I give you an example, it would be mass or volume or maybe entropy or enthalpy, right? Whereas in macroscopic, it is associated with the macroscopy system that consists of many particles. Like for example, it will become viscosity or pressure, right? Then comes laws of thermodynamics. There are three laws of thermodynamics, that is zeroth law, first law, and second law. The zeroth law deals with the thermal equilibrium among a system and the physical contact. In the first law, it states that energy can neither be created nor destroyed, but it can be transformed from one form to another. The equation for this law would be delta E that is the change in the internal energy is equal to Q minus W, where Q is the heat supplied to the system and W would be the work done by the system. In the second law, there were various statements that were passed, but what it basically states is that the work can always be converted into heat, but heat cannot be completely converted into work. Only a fraction of heat can be converted into work, and the rest remains unavailable or unconverted. So from the second law, various new equations and new terminologies came around, like entropy, enthalpy, Gibbs free energy, or the Helmholtz equation, etc. In the next video, we'll be looking into some of these equations and terminologies. That is it for this video. Thank you.